Hello everyone, we are from the Roy's Academy faculty team, and today we're going to be learning all about finding the nth term of arithmetic progressions. For similar video explainers, please connect with us at Roy's Academy on 8910890311. I'll repeat that number, 8910890311. Our other number is 8910600503. Repeating that one for you, it's 8910600503.
All right, let's dive right in. Welcome, everybody. Today, we're jumping into a really important concept from your CBSE Class 10 Math syllabus, which is Chapter 5, Arithmetic Progressions. And specifically, we're going to master the super useful skill of finding any term in a sequence, what we call the nth term. So, how are we going to tackle this? Well, we'll kick things off with a relatable story about a salary. Then, we'll use that story to figure out a really powerful formula. After that, we'll put the formula to the test, and finally, we'll use it to solve some pretty cool real-world puzzles. Sounds like a plan? Let's get started. Okay, let's start with a scenario I think we can all understand: money. You might be surprised to find out how something we learn in math class, like an arithmetic progression, shows up in everyday life, like in a yearly salary. So, imagine you get a great new job with a guaranteed pay raise every single year. Awesome, right? But what if you wanted to know your salary 25 years from now? Would you really want to sit there and add that raise 24 times? Of course not. That sounds so tedious and slow. There has to be a smarter way to figure it out.
Let's look at an example with Reena. She starts her job with a monthly salary of 8,000 rupees and gets a 500 rupee raise every year. So her salary creates this really predictable pattern: 8,000, 8,500, 9,000. This right here is a perfect arithmetic progression. That constant 500 rupee increase, that's our common difference.
So how would we calculate her salary in the fifth year? Well, we could add 500 4 times to her starting salary, but look how much cleaner and faster it is to just multiply 500 by 4 and add that instead. This is the big idea. We can trade slow, repetitive adding for quick, efficient multiplying. And this is the pattern that changes everything. For any year, you just take the starting salary and add the yearly raise, but you multiply that raise by the year number minus 1. See that? For the fifth year, we multiply by 4, which is just 5 minus 1. This little insight is the key that's going to unlock this whole topic for us. Now, this little trick works perfectly for the fifth year, but what about the 15th year, or that 25th year we talked about at the beginning? We need something better than a one-time trick. We need a universal tool, a general formula that works for any year without having to figure out the pattern all over again. So let's build that tool. We're going to take that simple pattern from Reena's salary and turn it into one of the most important and powerful formulas in this entire chapter.
And here it is, the formula for the nth term of an AP. It might look a little intimidating with all the letters, but AN equals A plus N minus 1D is basically our shortcut. This formula lets us leap forward to any term in a sequence, the 10th, the 100th, even the 1000th, in one single step.
So what does it all mean? Well, A is just the first term. In our example, Reena's starting salary of 8,000. D is the common difference, that 500 rupee raise. N is the number of the term we're looking for, like that 25th year. And A underscore N is the answer we want, the actual value of that 25th term.
Okay, the theory is great, but let's see this formula in action. It's time to actually put it to the test with a classic math problem. Here is a typical exam-style question. You have an arithmetic progression that goes 2, 7, 12, and so on. The goal is simple: find the 10th number in this list. So first things first, we always identify our key pieces of information. Our first term, A, is right at the beginning. It's 2. Our common difference, D, is just the gap between the numbers. So 7 minus 2 is 5. And since we want the 10th term, our N is 10. Now we just plug those values into our formula. The 10th term, or A10, is equal to 2 plus, in parentheses, 10 minus 1, all times 5. That simplifies to 2 plus 9 times 5, which gives us 2 plus 45. And just like that, we know the 10th term is 47. See how easy the formula makes it?
That was pretty straightforward. But what if the problem is flipped around? What if we already know the value of a term, but we need to find its position in the sequence? Let's try working backwards.
Check out this problem. The sequence is 21, 18, 15. Notice that this time it's a decreasing sequence. We're told that the number minus 81 shows up somewhere down the line. The question is, where? What is its term number? It's n. We use the exact same formula, but this time the unknown variable is n. We know a sub n is negative 81, a is 21, and our common difference d is negative 3. So we set up our equation. From here, it's just a bit of algebra. We simplify, we move things around to get the n by itself, and we solve to find that n equals 35. So negative 81 is the 35th term of this AP.
Now for the really cool part. Let's see how this formula can help us solve practical, real-world puzzles, just by learning how to spot the hidden arithmetic progression inside them.
So imagine this puzzle. A gardener is planting roses in rows. The first row has 23 plants. The second has 21, the third would have 19, and this pattern continues until the very last row, which has only 5 plants. The question is, how many rows of roses are there in total? The most important skill here is turning that word problem into math. You can see the AP, right? 23, 21, 19, all the way down to 5. This means our first term, A, is 23. The common difference, D, is negative 2, because the number of plants is going down. The last term, AN, is 5. What we need to find is N, the total number of rows. So, we just plug those values into our formula. 5 equals 23 plus n minus 1 times negative 2. And when we solve that equation for n, we get our answer. There are exactly 10 rows of roses in that flower bed.
And that really is the heart of it all. It doesn't matter if you're dealing with a salary, a list of numbers, or rows of flowers in a garden. The process is always the same. Find the pattern, identify A, D, and what you're looking for. Once you do that, the formula does all the hard work for you.
This was an initiative from the Roy's Academy faculty team, and today we've learned about a topic in CBSE Class 10 Mathematics, from Chapter 5, Arithmetic Progressions, finding the nth term of an AP. For obtaining similar explainers, please connect with Roy's Academy at 8910890311. I'll repeat that for you, 8910890311. Our other number is 891006000503. And again, that's 891006000503. Thank you for learning with us.